20 episodes, 6 hours, one model. We've traveled from Renaissance Florence to Republican Rome, from revolutionary Paris to modern democracies, from system dynamics to Bitcoin. Now let's step back and see the whole picture. What have we learned? What does Saylor's model actually tell us? What are its limits? And how should we think differently after absorbing it? This is the synthesis, the integration of everything we've covered into a coherent worldview. Let's recap the model in its essence. 5 state variables: W, wealth distribution; N, social norms; L, legislative position; E, executive power; P, production capacity. 6 parameters: A, wealth accumulation; V, norm regeneration; G, legislative responsiveness; D, executive power generation; E, production growth; T, time delays. A system of differential equations describing how these variables evolve and interact. The key insight: political economy is a dynamical system. It is equilibria, stable configurations where forces balance. It has feedback loops, mechanisms that amplify or dampen change. It has bifurcations, critical thresholds where equilibria appear or vanish. This isn't ideology. It's mechanics. The same framework that describes predator-prey populations or chemical reactions describes the rise and fall of empires. Understanding the mechanics doesn't tell you what to value or what to do, but it tells you what's possible and what's likely. It reveals the constraints within which political action operates. 10 key insights from the model. 1. Wealth concentration drives conflict. This is Machiavelli's fundamental observation formalized. High W generates pressure that systems must process or succumb to. 2. Norms are capital. N represents accumulated trust, legitimacy, shared expectations. It takes generations to build and can collapse quickly. It's the hidden variable that explains why identical institutions work in some places and fail in others. 3. Feedback loops determine dynamics. It's not enough to know the variables. You need to understand how they interact. Positive loops destabilize. Negative loops stabilize. The balance determines system behavior. 4. Multiple equilibria exist. The same underlying parameters can support different stable configurations: democracy or autocracy, high trust or low trust. Initial conditions and historical accidents determine which equilibrium a society reaches. 5. Transitions can be sudden. Bifurcations mean gradual change can produce discontinuous outcomes. Systems look stable until they're not. This explains why collapse often surprises contemporaries. 6. Early intervention is cheap. Far from bifurcations, small policy changes have large effects. Near bifurcations, even large changes may be insufficient. Timing matters more than magnitude. 7. Path dependence is real. History matters not just culturally, but structurally. Where you are in state space determines where you can go. Some transitions are irreversible. 8. Parameters can drift. The A, V, G that characterize a society change over time. Technology, culture, institutions, all shift the parameters. What was stable becomes unstable. 9. External factors matter. The model is closed system, but real societies interact. Trade, war, ideological contagion, international factors enter as shocks or parameter changes. 10. Models are tools, not oracles. The framework illuminates dynamics, but doesn't predict specific outcomes. Noise, contingency, and human agency remain. The model reveals recurring patterns across different historical cases. The Roman Republic and the French Revolution both show rising W plus, falling G plus, declining N, bifurcation, new equilibrium. The post-war democratic order shows moderate W plus, high N plus, high G, stable equilibrium. The current period shows rising W plus, falling N plus, declining G, drift toward bifurcation. The patterns recur because the dynamics are general. Class conflict, institutional sclerosis, norm erosion, executive aggrandizement. These aren't accidents or moral failings. They're the natural tendency of political economies under certain parameter conditions. This isn't determinism. Choices matter. But choices operate within constraints. Knowing the constraints helps make better choices. The model also explains variation. Rome took a century to transition. France took a decade. Rome ended in military empire. France cycled through regimes before stabilizing as democracy. Different parameters, different speeds, different outcomes, but same underlying dynamics. What the model doesn't capture: ideas and ideology. Beliefs shape behavior beyond material interests. The model assumes rational self-interest, but people fight and die for abstractions. Technology specifics. P is exogenous. We don't model how steam engines or semiconductors reshape parameters. Yet, technology is the biggest driver of long-term change. Culture and identity. N captures aggregate norms, but not their content. Whether a society organizes around ethnicity, religion, class, or nation matters, and the model doesn't say. Individual agency. Great leaders and contingent decisions disappear into differential equations. Would Rome have fallen without Caesar? Would France have stabilized without Napoleon? International system. The closed system assumption is a significant limitation. Hegemony, balance of power, economic interdependence all matter enormously. Normative guidance. The model describes what is and what's possible. It doesn't say what's good or what we should want. That requires ethics, not dynamics. These limits don't invalidate the model. They define its scope. Use it for what it captures. Supplement it for what it doesn't. How should we apply this framework? For understanding history, use the model as a lens. When studying a political transition, ask, what were the parameters? Which loops dominated? Was there a bifurcation? The model provides vocabulary and structure for historical analysis. For interpreting the present, track the variables. Is W rising or falling? Is N stable? Is gamma adequate? The model gives early warning indicators. Critical slowing down near bifurcations shows up as increased variance, longer recovery times, higher sensitivity. For evaluating policy, trace the feedback effects. A policy that reduces W might lower conflict, which strengthens N, which increases gamma, a virtuous spiral. Or it might trigger resistance that increases E, a different trajectory. Think in loops, not lines. For personal decisions, understand structural risk. If the model says your society is drifting toward bifurcation, that should inform where you live, what you invest in, how you prepare. This isn't pessimism or optimism, it's analysis. For building institutions, design for stability. Include negative feedback loops. Avoid reinforcing loops that could run away. Build in mechanisms that constrain E and maintain gamma. Constitutions that last embody this wisdom implicitly. Where should political economy research go from here? Better data, estimating WNLEP from historical and contemporary data, moving from qualitative pattern matching to quantitative calibration. Agent-based extensions, moving beyond aggregate variables to heterogeneous populations. Modeling how individual decisions aggregate to system behavior. International coupling, linking multiple national models through trade, war, and contagion. Understanding how local dynamics create global patterns. Technology integration, endogenizing P and modeling how technological change affects other parameters. Understanding how AI, biotech, and digital systems reshape political economy. Experimental validation, using natural experiments, policy changes, and historical shocks to test model predictions. Building confidence intervals around bifurcation estimates. Normative theory, connecting positive models to ethical frameworks. What equilibria should we want? What trade-offs should we accept? The 1983 thesis was a beginning, not an end. 40 years later, the agenda it set remains relevant and mostly unfinished. What worldview emerges from this framework? Politics is not about good versus evil. It's about managing inevitable conflicts generated by material conditions. Morality matters, but moralizing doesn't change parameters. Stability is precious and rare. Most configurations are unstable. Finding and maintaining a good equilibrium, one with moderate inequality, high trust, responsive institutions, constrained executive power, is a civilizational achievement that requires constant maintenance. History rhymes because dynamics recur. The fall of republics, the rise of autocrats, the cycles of revolution and reaction, they happen repeatedly because the underlying feedback loops are general. Agency exists within constraints. We can choose policies, build institutions, shape norms, but we can't repeal the laws of political dynamics any more than we can repeal gravity. Effective action works with the constraints, not against them. The future is uncertain, but not random. We can't predict which scenario will occur, but we can understand the forces at play and the conditions under which different outcomes become more or less likely. This is neither optimistic nor pessimistic. It's realistic. Seeing clearly what is, as Machiavelli insisted, rather than what we wish it to be. We've built something in this course. Starting with Machiavelli's qualitative insights, we formalized them into system dynamics. We identified variables, parameters, feedback loops, and equilibria. We simulated scenarios and analyzed stability. We applied the framework to Rome, France, and the present. The result is a lens, a way of seeing political economy that reveals structure beneath surface. You now have this lens. You can apply it to news events, policy debates, historical analyses, investment decisions. You can ask the questions. What are the parameters? Which loops dominate? Are we near a bifurcation? Last episode, we'll conclude the series with reflections on Machiavelli, Saylor, and what it means to think like a political economist. We've done the work. Now let's step back and appreciate what we've learned. Next time, series finale.